Okay, what we are doing today is we're looking at piecewise functions. So we were actually introduced to piecewise functions back in our topic of functions and other graphs, so topic 3, chapter 4, okay, when we were looking at domain and range. So a piecewise function is a function made up of two or more different functions defined for different intervals in its domain. So we can look at the different functions over their specific domains. So we are going to graph this piecewise function to start off with. So fx is equal to 2x plus 1 when x is less than minus 1, and it's equal to 3 when x is greater than or equal to minus 3. So we have two linear functions and we're going to graph each one separately. So our first function is equal to 2x plus 1, okay? And we have our domain is that x is less than negative 1. So what we can do is, starting at negative 1, we can find out what that value is. So we can substitute in, so let x equal negative 1, and we will then have f of negative 1 is equal to 2 lots of negative 1 plus 1, and that is equal to negative 1, okay? Then we can do the same with our other values, so let x equal negative 2 as we go down, so f of negative 2 is equal to 2 lots of negative 2 plus 1, which is negative 3, and we can keep going, etc. Now, what we have is, as x is less than negative 1, we have to use an open circle. As it doesn't exist at x equals negative 1 for this function. Okay, that's what it means when we have just our less than. Okay, so it means it doesn't exist there. You kind of need a ruler because these are linear functions that we're drawing. Okay, so if you don't have a ruler, get up and grab one. But what we can see also is, because it's a linear function, we do have our gradient. So we're going to, I'm going to put a very small dot at minus 1, and then we have minus 2, minus 3. The next one will be minus 3, minus 5. Okay, I'm going to draw my line stopping at x equals minus 1, but it continues down, and I'm going to draw an open circle there and put my arrow on the end. Okay, then my second part of my function is is equal to 3 for our domain of x is greater than or equal to minus 1. So that is just the line y equals 3. So from negative 1, I'm going to draw my line y equals 3, which is a horizontal line going across. And I'm going to make sure I do my arrow. And I'm going to make sure I do a nice big closed-in circle so that it is continuous. So that we know that it exists there. Do I need to write something about doing a closed-in circle, or yeah? As x is greater than or equal to minus 1, use a closed circle. Do it in orange. Actually, I'll just use blue. As it exists at x equals minus 1. Okay, one more thing that we want to discuss is whether this function, so this is our function y equals f of x. We don't need to write our different parts of our function. We can just call it y equals f of x because we have it written up above. Okay? What we have is f of x is discontinuous at our x equals minus 1, okay, because it doesn't connect. We're going to see some functions shortly that do, like when you're having a go at them, that do connect. Now for this one, our domain is just negative infinity to infinity, so it exists at all of our x values if we wanted to write that down. Anyone got any questions? No? Okay. The next one here, we want to sketch fx equals x squared when x is less than 0 and x cubed plus 1 when x is greater than 0. So what we have is our first function is equal to x squared for the domain x is less than or equal to 0. Okay, so that is our parabola on the left-hand side. So we are going to have that if we let x equal 0, we'll have f of 0 equals 0 squared, which is just 0. Let x equal 1. Oh, sorry, minus 1, because it is when it's less than 0. So f of minus 1 is minus 1 squared, which equals 1. And then we could just do let x equal minus 2. F of minus 2 is minus 2 squared, which equals 4. Okay, so because we have as x is less than or equal to 0, we use a closed circle for this function. Okay, so we can sketch that. So it's 0, 0, minus 1, 1, minus 2, 4, and then it's also at minus 3, 9. I can do that by checking in my calculator what happens at minus 3. And it is a parabola. I might draw that again though. Still not happy. Okay, so try and make it nice and curved, and we want a nice closed in circle there at 0, 0, at x equals 0. Okay, it's a parabola. Our second function is equal to x cubed plus 1, and our domain is x is greater than 0. Now our x cubed function is a cubic. Okay, so if we see what happens when we let x equal 0, we get f of 0 is equal to 0 cubed plus 1, which is just equal to 1. And then if we let x equal 1, f of 1 equals 1 cubed plus 1, which is 2. And if we let x equal 2, we have f of 2 is equal to 2 cubed plus 1, which is 9, because 2 cubed is 8, plus 1 is 9. Okay, so then what we have is we have a cubic, I've drawn that pretty badly, Give me 2 seconds. Okay, like so, and we want to make sure there is a nice open circle there as x is just greater than. Okay, we also have that fx is discontinuous at x equals 0. Okay, and we can just write that this is y equals f of x on our function.